Water, the most ordinary substance on Earth, and yet one of the most powerful industries ever created. Every second, somewhere in the world, more than 20,000 bottles of water are being opened. Not because people are thirsty, but because they trust what's inside those bottles more than what flows from their own taps. But have you ever stopped to ask yourself, where does bottled water actually come from? And how does a simple liquid become a multi-billion-dollar global empire? Welcome inside a modern bottled water factory. Before we step through these doors, take a moment. What you're about to see isn't just machines and pipes. It's a system engineered for speed, precision, and psychological trust. If you enjoy deep dive documentaries that reveal how the world really works, subscribe now. This channel explores the hidden systems behind everyday life. Behind thick concrete walls and security checkpoints, the factory operates almost silently. No crowds, no chaos. Just the low mechanical hum of machines that never sleep. Here, water is no longer just water. It is a product, a promise, and a brand. The modern bottled water industry didn't rise by accident. It was born from fear. Fear of contamination, fear of illness, fear of uncertainty. In the late 20th century, public trust in municipal water systems began to crack. Headlines about pollution, aging pipes, and chemical runoff spread across the world. Companies saw an opportunity. They didn't sell water. They sold safety. Today, bottled water generates hundreds of billions of dollars annually, surpassing soda in many countries. And yet, most consumers have no idea what happens between the source and the shelf. That changes now. As the factory doors slide open, the first thing you notice is the air. Filtered, pressurized, controlled. Every detail inside this facility is designed to prevent contamination. Hairnets, gloves, protective suits. Even the air itself is monitored for particles invisible to the human eye. Because in this world, purity is currency. Long stainless steel pipelines snake through the ceiling like arteries, carrying thousands of liters of water per hour. Digital screens flash numbers most people would never understand: flow rate, conductivity, mineral balance, bacterial count. This isn't guesswork, it's science at industrial scale. But here's the twist. Despite the pristine environment and advanced technology, the biggest challenge for bottled water companies isn't filtration, it's trust. Consumers don't buy bottled water because it tastes better. They buy it because they believe it's safer. And everything you're about to see is carefully designed to protect that belief. In the next segment, we'll trace the journey of water from its original source, whether deep underground aquifers, protected springs, or even municipal supplies, and uncover a truth most brands rarely advertise. Because not all bottled water is what you think it is. And once you understand where it really comes from, you'll never look at a plastic bottle the same way again. Every bottle begins with a question most consumers never ask. Is this water natural or engineered? The answer depends on the source. Despite the images on labels, snow-capped mountains, untouched springs, pristine forests, modern bottled water usually comes from three primary sources. The first is natural springs. These are underground reservoirs where water has flowed through layers of rock for decades, sometimes centuries. Minerals dissolve naturally along the way, giving the water its unique chemical signature. At the factory, spring water arrives through protected underground pipelines or is transported in sealed tanker systems. Sensors immediately test for temperature, mineral content, and microbial presence. Any deviation, even microscopic, triggers an automatic shutdown. But spring water is rare and expensive. That's why many companies rely on the second source: deep groundwater wells. These wells can reach hundreds of meters below the surface, tapping into ancient aquifers isolated from surface pollution. Massive electric pumps pull water upward with relentless force, operating day and night. What most people don't realize is this: extracting groundwater at industrial scale permanently alters local ecosystems. In some regions, water tables drop, wells dry up. Local communities begin to compete with corporations for access to the same resource. Yet inside the factory, the process looks clean. Efficient, justified. Because here, water isn't seen as a shared resource, it's a licensed asset. Then there's the third and most controversial source. Municipal water, yes. In many cases, bottled water begins its life as the same water flowing through your kitchen tap. The difference lies in what happens next. Once municipal water enters the factory, it undergoes an intense purification process, often more advanced than public treatment systems. Reverse osmosis strips everything away. Minerals, chemicals, even taste. What remains is nearly pure HOO. Then, something interesting happens. The minerals are added back in. Calcium, magnesium, potassium, not for health, but for flavor, consistency. Because consumers expect bottled water to taste the same every single time, no matter where it's produced. At this point, the water is no longer natural, it's formulated. And that's not necessarily bad, but it is rarely explained. Inside the factory, automated valves redirect the purified water into massive holding tanks. Each tank holds enough water to fill tens of thousands of bottles. No human hands touch it. From this moment forward, everything is controlled by algorithms. In the next segment, we'll enter the heart of the factory, the filtration and purification zone, where invisible threats are eliminated at molecular levels. And you'll see why the cleanest water in the world isn't found in nature, but inside machines. Inside the factory, water enters a place few people will ever see. This is not where water becomes clean. This is where water becomes controlled. The filtration hall stretches wider than a football field. Stainless steel dominates the room. Pipes, tanks, membranes, all gleaming under sterile white lights. Every surface is designed to resist corrosion, bacteria, and human error. Because here, the enemy is invisible. Bacteria, viruses, chemical residues measured in parts per billion. The first line of defense begins with multi-layer mechanical filtration. Water flows through progressively finer filters, each stage removing larger particles, sand, sediment, organic debris. What survives this stage isn't visible to the naked eye, so the system gets more aggressive. Next comes activated carbon filtration. Thick columns packed with carbon granules strip chlorine, odors, and volatile organic compounds from the water. Sensors constantly monitor absorption levels, alerting technicians the moment efficiency drops. But the real transformation happens deeper inside the system. This is where reverse osmosis begins. Under immense pressure, water is forced through membranes, so fine that even dissolved salts cannot pass. What emerges on the other side is water in its purest industrial form, stripped of nearly everything that once defined it. No taste, no minerals, no identity. At this stage, some people would call it dead water. Inside the factory, it's called blank slate. And that's exactly what the industry wants, because consistency is everything. Every bottle must taste identical, whether it's produced in Asia, Europe, or North America. Nature can't guarantee that machines can. But purity alone isn't enough. Even after reverse osmosis, water faces its most intense enemies, yet microorganisms, small enough to survive extreme conditions. That's where UV sterilization takes over. As water flows through transparent chambers, powerful ultraviolet light disrupts the DNA of any remaining bacteria or viruses. They are not filtered out, they are rendered unable to reproduce. Destroyed, without chemicals. Then comes the final safeguard, ozonation. Ozone gas dissolves into the water, acting as a temporary but brutal disinfectant. It kills anything that survived before, and then disappears, leaving no taste, no residue. It's clean, clinically clean. But something is missing. Water without minerals doesn't taste like water, and humans notice. Which leads us to the next stage, a step that transforms sterile liquid into a consumer product. In the next segment, you'll see how factories engineer taste, rebuild minerals, and fine-tune water chemistry. Not for health, but for psychology. Because the perfect water is designed, not discovered. Once stripped to its purest form, water reaches a crossroads. Remain sterile and flavorless, or be rebuilt. Inside the mineralization chamber, precision replaces nature. Here, computers control what once took centuries underground. Valves release microscopic doses of minerals back into the water. Calcium for smoothness, magnesium for a crisp finish, potassium for balance. Every brand has its own formula. Not a recipe, a signature. These mineral profiles are guarded like trade secrets. Technicians aren't told why certain ratios exist, only that deviation is unacceptable. Because studies show something fascinating. Most people can't describe the taste of water, but they can tell when it's wrong. That's why factories constantly sample water using automated tasting systems. Yes, machines can now detect taste differences humans might miss. Consistency is everything. A bottle bought today must taste identical to one bought 6 months from now. Otherwise, trust breaks. And in the bottled water industry, trust is the product. Once mineralization is complete, water flows into sealed buffer tanks under positive air pressure. Nothing enters unless it's filtered. Nothing leaves unless it's approved. At this point, the water is no longer raw material. It's finished, but it's still invisible to consumers. So the next step is where perception takes over. Because people don't just drink water, they judge it by the bottle that holds it. In the next segment, we'll follow the journey of molten plastic transformed into thousands of bottles per hour, and see how packaging plays a far greater role than most people realize. From design to safety, to environmental consequences rarely shown in advertisements. Long before water touches plastic, the bottle already exists, just not in the form you expect. It starts as something no larger than a marble. Inside massive silos, millions of tiny plastic pellets wait in silence. This is PET polyethylene, terephthalate, chosen not for beauty, but for strength, clarity, and safety. From here, speed takes over. Pellets are fed into injection molding machines, where temperatures exceed 270 degrees Celsius. The plastic melts, flows, and is injected into steel molds with microscopic precision. In less than 10 seconds, the result emerges. They look like thick test tubes with bottle caps already formed. At this stage, they are useless to consumers, but perfect for factories. Why? Because preforms are easy to store, easy to transport, and impossible to contaminate. Robotic arms move them without human contact. Every gram of plastic is measured. Any deviation is rejected automatically. Then comes the moment of transformation. Preforms enter blow molding machines, where compressed air stretches them inside bottle-shaped molds. In a single explosive motion, the plastic expands outward, locking into its final shape. 1 second. That's all it takes to turn molten polymer into a recognizable bottle. The machine doesn't stop. Hundreds of bottles per minute pour out in perfect symmetry, identical in weight, thickness, and transparency. Cameras inspect each one. Too thin, rejected. Deformed neck, rejected. Micro crack, invisible to humans. Rejected, nothing is forgiven. Because once filled, a defective bottle is a disaster waiting to happen. Pressure, transport. Temperature changes. A single failure can destroy thousands of bottles in seconds. That's why factories invest millions to prevent it. But manufacturing the bottle is only half the story. Because plastic doesn't just hold water, it shapes how consumers perceive quality. Smooth curves signal purity. Sharp angles suggest strength. Minimalist design whispers premium. Every bottle is engineered to influence the subconscious. And now, with bottles rushing forward on conveyors at breathtaking speed, they are ready for their true purpose, to be filled. This is where chaos would happen, if humans were in control, but they're not. Inside the filling hall, machines dominate everything. Bottles race along conveyor belts at speeds faster than most people can track with their eyes. They are flipped, aligned, and spaced perfectly, never touching, never colliding. Above them, a sealed filling carousel spins like a mechanical storm. This is the heart of the factory. Before water enters, the bottles undergo air rinsing using sterile, filtered air. No water is wasted. No contamination is allowed. Then, in perfect synchronization, filling nozzles descend. Water flows, not splashing, not foaming, measured to the milliliter. Sensors adjust flow in real time, compensating for temperature and pressure. If a nozzle deviates even slightly, the entire line can stop instantly. Why? Because a single overfilled bottle can break downstream equipment. A single underfilled bottle can trigger consumer complaints and recalls. Immediately after filling, caps are applied at extreme speed. Torque is measured automatically. Too loose. Rejected. Too tight. Rejected. Nothing relies on feel. Everything is data. The environment is pressurized with HEPA filtered air. Workers wear protective suits, not because water is dangerous, but because humans are. Every breath carries risk. That's why some modern factories run entire shifts without a single person touching a bottle. Lights are dim. Machines don't need them. Cameras do. Thermal sensors watch motors. Vision systems check fill levels. AI detects anomalies long before failures happen. This is manufacturing as choreography. Silent, relentless, perfect. And yet, even now, the product isn't finished. Because a bottle of water without identity is just a liquid in plastic. In the next segment, we'll see how labels, branding, and psychology transform anonymous bottles into trusted global products, and how one tiny error can destroy an entire batch. At this stage, the water is flawless. The bottle is perfect. The seal is secure. But none of that matters if people don't trust it. Trust is not built by purity alone. It is built by appearance. Inside the labeling hall, thousands of identical bottles move forward, naked and anonymous. Within seconds, they will receive their identity, their name, their promise, their story. Labels arrive in massive rolls, printed with microscopic precision. Colors are calibrated to exact wavelengths. A shade too dark, too light, or slightly misaligned can trigger rejection. Because branding is not art. It is engineering. High-speed labelers wrap bottles in a blur of motion. Glue-free systems use heat and pressure to fuse films seamlessly to plastic. Cameras instantly verify alignment, font clarity, and barcode readability. A crooked label is not a cosmetic flaw. It's a liability, because consumers subconsciously associate symmetry with safety. Studies show people trust products that look balanced, clean, and consistent, especially when it comes to something they ingest. And bottled water companies know this better than anyone. The words on the label matter too. Natural, pure, spring, protected source. Each term is legally defined, but strategically chosen. They don't just inform, they reassure. Every claim must match regulatory standards across multiple countries. One bottle might cross 5 borders before reaching a shelf. Each market has its own laws, languages, and consumer fears. That's why factories print different labels for different regions, sometimes on the same production line. Switching takes seconds. Mistakes are unforgiving. One incorrect word can cause recalls costing millions. But trust isn't only visual, it's emotional. That's why branding extends beyond the label into the shape of the bottle, the texture of the plastic, even the sound the cap makes when opened. Yes, the sound. That click tells your brain the bottle was sealed, that it was untouched, that it's safe. Everything is designed to remove doubt. And once labeled, the bottles move forward, no longer just products, but promises. Promises that now must survive a brutal journey. Speed increases again. Bottles group together, forming precise rows. Automated packers wrap them in shrink film, sealing dozens at once. Heat tunnels tighten the plastic until each pack becomes a single rigid unit. Efficient, stable. STACKABLE. Next comes palletizing. Robotic arms lift entire cases effortlessly, stacking them in mathematically perfect patterns. Weight distribution is calculated down to the kilogram. Too much pressure in one corner, and bottles collapse during transport. Too little tension, and loads shift at sea. Everything here anticipates movement, because the factory is only the beginning. Once sealed, pallets are wrapped, labeled, and scanned into digital logistics systems. Each one receives an identity, trackable in real time across continents. Where it's going, how long it will take, what temperature it must stay at. A single pallet might travel thousands of kilometers by truck, by train, by ship. Every delay costs money. Every deviation risks damage. And water is heavy. That's why logistics is one of the biggest expenses in the bottled water industry. Transporting liquid is inefficient, but unavoidable. Some factories exist solely because they are closer to consumers. Others because they sit near strategic transport hubs. Location is power. Inside control rooms, logistics managers watch digital maps glow with movement. Trucks depart in synchronized waves. Containers are loaded on tight schedules. Missed windows mean missed profits. But logistics is also where the industry faces its greatest criticism. Carbon emissions, plastic waste, water extraction impacts. These questions don't stop the machines, but they shape the future. Which brings us to the final stretch. In the next segment, we'll confront the environmental cost, the innovations trying to solve it, and the future of bottled water itself. Because the industry is changing, whether it wants to or not. For all its precision and efficiency, the bottled water industry carries a weight no machine can hide. Convenience has a cost. Every bottle represents extracted resources, water pulled from the earth, plastic derived from fossil fuels, energy consumed to shape, fill, seal, and transport it across vast distances. And the numbers are staggering. Billions of bottles are produced every year. Even with recycling programs in place, a large percentage never returns to the system. They end up in landfills, rivers, and oceans, long after the water inside has been consumed. Inside corporate boardrooms, this reality can no longer be ignored. Public pressure is rising. Regulations are tightening. Consumers are asking harder questions. In response, the industry has begun to adapt. Factories now experiment with lighter bottles, reducing plastic use by grams that add up to thousands of tons annually. Others introduce recycled PET, blending old plastic into new bottles. Some brands invest in plant-based plastics, attempting to break dependence on fossil fuels, though scalability remains a challenge. Water sourcing is under scrutiny too. Companies publish sustainability reports, promising responsible extraction, aquifer monitoring, and community reinvestment. Sensors now track groundwater levels in real time, ensuring pumping stays within regulated limits. But critics argue it's not enough. Because, at its core, bottled water solves a trust problem, not a water problem. In many regions, tap water is already safe. Bottled water thrives where confidence is low. Which raises a deeper question. Is the industry addressing environmental impact or protecting its business model? Inside factories, change is slow but visible. Solar panels power auxiliary systems. Energy-efficient motors replace older equipment. Wastewater is recycled internally. Production data is analyzed to eliminate inefficiencies invisible to humans. The machines are evolving, but the debate continues. And the future of bottled water depends on what happens next. As the factory quiets down, one truth becomes clear. This place is not just about water. It is about how modern society organizes trust, resources, and technology. In the future, bottled water may look very different. Smart bottles with tracking chips. Localized microfactories closer to consumers. Packaging that disappears after use. Or a return to public systems rebuilt with transparency and technology. Automation will deepen. AI will predict failures before they happen. Factories may run entirely without lights, because no humans will be inside. But the central question will remain: who controls water, and why? Because water is not just a product, it is life. And the way we manage it reflects what we value most: convenience, profit, sustainability, or responsibility. Understanding this factory means understanding more than machines. It means understanding the systems that quietly shape our world. And once you see them, You can't unsee them. If you want to uncover the hidden industries that power modern life, subscribe to Industrial Insight. Like this video to support deep industrial documentaries. Comment which industry we should explore next. Because the future isn't built in public. It's built inside places like this. Industrial Insight, where the world is built.